Alright, welcome back, fellow Bitfrogs. Today is the second, or technically the third video on how to recreate a 2D platformer for the NES in Godot. In the previous episode, I was telling you that we would need to write some code, and we're gonna have to do that today. So put on your big boy pants, because we are not getting away from that. We also need to deal with a tiny little situation that arose. A tiny little oopsie. A little, I changed something off camera and now everything looks like a crime scene. If you recall, at the end of episode 1, the level 1 looked fine. It was playable, respectable, not great, but it worked. A level you might proudly show to your mother and she'll go, "Oh, that's nice, sweetie," without even looking at it. But between recordings, I made some changes to the tile set, changes that I didn't properly think through, and now our beautiful level 1 looks like someone loaded the wrong texture pack in Minecraft. So, our first task of the day is to repaint the entire level. Well, that's not actually going to be that difficult. If you haven't downloaded the new sprite sheet, this isn't going to be an issue for you, but since we'll be working with that from now on, just go down to the description of the video and you'll get it, and replace the old sprite sheet with it. You'll be done. But open up the level 1.tscn, the scene level 1, and select the tile map layer and take a deep breath. Yes, everything is wrong. Yes, nothing is lined up. Yes, this is entirely my fault. So we are going to repaint the map using the new tile set, but this time we'll use the square tool, and seriously, use the square tool, you really should. And make sure each tile is actually the tile we think it is, and then we're going to double check the corners, the inner corners, and the center tiles of everything. When painting an NES era map, you will notice a pattern. The grass blocks, for example in my sprite sheet, they have corner tiles, they have inset corner tiles, they have middle tiles, and this is how nearly every old tile map works. Some games would maybe use a full 9-way tile set with top, right, bottom, left, and top, left, plus the middle. You see this a lot in overworld maps in games like Final Fantasy 1, Dragon Warrior, or Super Mario Bros. 3, where the landscape needs to look rounded and organic. But in a simple side-scrolling platformers like ours, we usually don't need all 9 directions unless we're making floating platforms. And for now, we just need the top edge and the bottom edge, the corners, and the middle. So go ahead and repaint the ground, the top grass layer, and then carve out the pit where Pim will inevitably fall to his death. Because as of this moment, falling is Pim's only natural talent. Well, not even that, as we'll see soon. While you're doing this, you're about to notice something very striking. The gradient tiles at the top of the pit are going to look a little weird. They're meant to show darker shadows, a deeper section of the ground. This is a classic NES trick, using black to sort of create the illusion of a shadow becoming darker. There is, however, a catch to this. Some gradient tiles have transparent pixels, ours in particular. And what does that transparency show? Well, it doesn't show the background tile, it doesn't show the sky, it shows the default background color of the engine, which, if you recall, isn't exactly the kind of blue we want. So you'll see this immediately. The transparent parts of the gradients don't match the cloud color background, so suddenly our pit looks like it's filled with, I don't know, blue Kool-Aid. We have 2 ways to fix this. Either we do it the proper way or the easy way, and we're going to do it the easy way. The proper way would be to edit a PNG and replace the transparent pixels with the correct shade of blue, but that does sound like a lot of work, and this is episode 2, we're not going into Photoshop 101 here. So we're going to cheat. Go to Project, Project Settings, Rendering, Environment, and Default Clear Color. And like we did in the last video, we're going to change it to the same blue that's used in the background for the clouds. Instant fix. Perfect. We're back on track. So, Bitfrogs, now we're going to the actual new part of all this. We have repainted the level, we fixed the tiles, we fixed the background, and everything looks nice and tidy. And Pim is still just standing there, absolutely still, motionless. A tiny pink Buddha in a field of grass, if you will. And it's time to change that. Today, Pim is going to learn 3 things. He's going to learn how to walk left and right, how to fall correctly, and how to stop falling straight into HE double hockey stick. And the last part is very important. Head down to the file system in the lower left corner, right-click on Scripts and choose New Script. Name it player.gd, because naming scripts after the nodes they control will save you from a lot of headache when your project is a lot bigger. Now once you've done that, drag player.gd onto the player node in your player scene. Not the sprite 2D, the root player node, the character body 2D. Once you've done that, open up the script and change extends node to extends character body 2D. This gives us a lot of things actually. It might not seem like it to begin with, but character node 2D comes with a lot of built-in functions and abilities. For example, it handles velocity, we got gravity helpers, we got collision methods, and floor detection, and that's just a little sample of everything it's going to give us. So after that, we're going to add class name player. And this is going to make it a lot easier for us to reference this script from other scenes later. Not relevant right now, but just put it in place and trust me, okay? Once that's done, we're going to create something called physics process delta. And first of all, you got to type that out. So this little function is basically going to be the most important variable in the entire episode. There we go. Now we're going to move on to the top of the script and we're going to add 3 variables. They're going to be move speed, jump speed, and gravity. So type in @export space var space move underscore speed colon space float space equals to space 60. That's a mouthful. Now do the same with jump speed and gravity and give them some numbers. Move speed is going to be 60. And that is how fast Pim is going to walk. It's 60 frames per update. Or 60 pixels per update, sorry. There's going to be jump speed, which is 200 pixels. Don't worry about it. 200 pixels, just type that in. Don't even worry about it. Why are you looking at me like that? Don't worry about it. Anyway, finally, gravity is going to be 400, and that's the force that's kind of pulling Pim down towards the ground. The jump speed is how high Pim is going to jump before that happens. Yeah, don't worry about it. Yeah, anyway, type in var input underscore dir, or dir, colon space float equals 0.0. What does that do? I'm glad you asked. That's going to help us decide which direction Pim is going to be moving towards. Is it going to move left or is it going to move right? And to explain how this works, if input direction is 1, that means that Pim is going to move right. Because on the x-axis, minus and plus are left and right respectively. If you kind of look at it like a cross-section, anything behind the cross-section to the left is going to be minus, and anything to the right of the cross-section is going to be plus, going to be positive, and it's like math, right? And if it's on 0, nothing's going to happen. It's just going to be Pim standing there looking stupid, which he's very good at. So this little variable is basically going to change depending on which direction we're moving. So now we're going to put in some if and else if here. So if input dot is underscore action underscore pressed D left. You remember that? D left, that's the thing we created before, the direction left, the D-pad, the direction pad. If that is being pressed, input direction is going to be -1. If, or rather else if it is pressed D right, if D right is being pressed, input direction is going to be 1. This is exactly how early NES games would operate. There aren't any analog sticks, there's like no 360 degrees of movement, there's no curving, no easing, no physics, it's just left, right, up, and down. Some games maybe implemented diagonal movement, kind of, but that's way later. We'll get to that bridge when we get to it. That's not how that saying goes. Anyway, Now we turn this whole thing into movement. So, if input direction is not 0.0, and the little exclamation mark here means that it's not, if that is not 0.0, velocity.x equals input direction times move speed. Now move speed is a variable we created up there at the top of the screen, and that's 60. So if the direction isn't 0, the velocity is the speed of Pim moving around is going to be the direction, either -1 or 1, and times the movement speed. And if it is 0.0, then velocity is obviously going to be 0.0. We're standing still. Pretty simple stuff. Now you can test it, and you'll see that Pim is moving left and right, just the way we wanted it to. Just going left, and then going right. No problem. Except that he's not falling. And now we have to make him fall. So we have to get on with gravity. So while we're still inside the physics process, I want you to add if not is on floor. You can see me typing it out there. Velocity.y plus equals gravity times delta. Yeah, you just typed that out. That basically means that gravity times the updates per second. I'm not entirely sure what delta is. It's like related to how fast your computer is. If he is not touching the floor, and is on floor is a built-in function in Godot. We don't need to define this. This is already in. If he is not touching the floor, his y speed is going to be gravity times delta. Now you can run the game, and yeah.
Just you know why.
Yeah. Pim just fell straight through the ground. Like, straight down to HE hockey stick. Why? Because there's nothing in our level that's actually considered floor yet. You didn't think it would be that easy, did you? Because right now, the tiles that we have painted out, they don't have any physics layers, they don't have any collision, and they don't even know that Pim exists, which is kind of a sad thought. So we're going to go back to the tile map, and we're going to fix that. So once again, we're going to go back to our chr.tres, the tileset resource, and click physics and add a physics layer. Now, if you go to the bottom and click the tileset dock, you will find the tab called Physics Layer. Physics Layer 0 is the area where you define collisions. I know I'm throwing around a lot of terms here. Don't worry about it. If you have any questions what these things mean, just ask me. Hopefully they should be sort of self-explanatory. But what we did is that we added a layer of physics onto this tile set. That doesn't mean that they have physics yet, it just means that we can put physics onto it. So once you've done that, once you have physics layer 0, select your ground tiles in the tile set, and then scroll down in the inspector that pops up, find physics layer 0, and click F to autofill the tile's entire shape. You might have to click in the tile window that pops up to do that, but if you press F on the keyboard, the whole tile will become red, tinted red. And that means that it is now considered a physics shape. In fact, this basically just tells Godot, these tiles are solid. Pim should not fall through them, please. So now if you go back to level 1 and run the game again, Pim is still falling straight through the floor. It's cool. Don't worry. We'll fix this. We're just missing one little thing, and then Pim is gonna stay out of hell and be right where he's supposed to be. While we can see Pim's sprite, and while we can move it around, he is only visually existing. He doesn't have a physical body in the game, if that makes sense. In games, we have hitboxes. Hitboxes are where collisions happen. If you don't have a hitbox, you can't collide with something else in games. This goes for 2D games and for 3D games. Thankfully, Godot has a pretty simple way of implementing these. First of all, we're going to go back to the player, we're going to select the player node, and we're going to add a child called Collision Shape 2D. Collision Shape 2D is essentially a hitbox, a two-dimensional hitbox. It doesn't have a Z value, it has an X and Y value. Now in the inspector, to the right, you choose a rectangle shape 2D. That's going to be the shape we use, and pretty much the basic shape for anything NES generation in terms of hitboxes. You can, of course, have multiple smaller hitboxes, that's okay, because the way the NES was programmed was that they would basically tell the NES these pixels are going to be hitboxes, and those could be in any kinds of shapes. That wasn't really a limit to the NES, as far as I know. Anyway, once we made this rectangle shape, we're gonna... Rectangle. Once we made this shape, you just kind of move it around until it roughly fits Pim's body. It doesn't have to be perfect. You can make the hitbox smaller if you want, but it is my strongest recommendation that the hitbox does line up with his feet, so you don't get that little space between him and the ground. Now you can test the game again, and voila! Pim is landing on the ground. He's standing there, he is not falling through the ground, he is no longer falling into the abyss like a pink bowling ball, unless, of course, we move him over to the pit, and down he goes. Perfect! Pim can now move left, Pim can fall, Pim can not fall through the floor, normally, and now it is time to give him the most classic platformer ability in human history.
Stomping Koopas.
Jumping. Yeah, jumping. Stomping on stuff is gonna happen later, but right now he's gonna be able to jump, because there's no way he's gonna get across this pit if we don't give him that ability. And I promise you, this is where everything is going to go wrong in the funniest way possible. So, right now, we only have this. If not is on floor, velocity.y is plus equals gravity times delta. That means that if Pim is in the air, gravity pulls him down. If Pim is on the floor, nothing special happens. That doesn't work with Pim jumping though, because if Pim is jumping, he is going to be in the air, so he would be immediately dragged down, right? So we need to sort of bypass this and make it so that if the button has been pressed for jumping, he should be jumping first before he gets pulled down. So let's rewrite the gravity section a little bit. If not is on floor, velocity.y plus equals gravity times delta. That's the same, we're keeping that. Else, if input dot is action just pressed button A, velocity.y equals jump speed. Now we hit play, we press jump, and Pim does absolutely nothing. Not even a twitch. No hopping, no effort. This is where real game development begins. Debugging. So first we're going to check the obvious, right? We're going to make sure that our button A is assigned to the input map. Yes, it is. Is it bound to a key we're pressing? Yes, it is. Is action just press button A fire? Well, let's check if it does. Maybe the game thinks that Pim is never on the floor. Add print on floor. Is on floor. Run the game, and the result should be popping up. It should be saying true. So floor detection seems to be working. Alright. In the if input is action just pressed. Print, jump button pressed. Now, if we run the game and hit the key and look at the output, it prints. So the input system is fine. Okay, so now we're stuck. The code is fine, it works, the inputs works, the floor detection works, gravity works. Pim just doesn't want to jump. It's really weird. Not actually that weird. Because after we've looked at the code for a little bit, something I said a few minutes ago suddenly comes to mind, right? Think of it as an axis. 0 and 0 means that you're in the middle of two crossed lines, right? You have on your left -1, on your right +1. And that's just how it goes. It's a graph. What about y? We already know that positive 400 is gravity, right? Because gravity is 400, and velocity y is going to be gravity, and Pim falls down a hole. So 400y is actually downwards. Now, we did something a little while back. We made a little mistake. I made a little mistake. I wrote the jump speed is going to be 200. 200. Not negative 200. 200. Are you seeing the problem right now? Because I'm seeing the problem right now. Pim isn't jumping up. Pim is trying to jump down. And we were trying to make him drill into the ground, not, soar through the skies. So the code wasn't wrong. He was jumping. It's just that he was jumping very hard into the ground, and the ground wasn't having it. So the physics engine is completely correct. Pim was doing what I told him to do. I screwed up. This is a very easy fix. Just add a minus. There you go. Jump speed minus 200. Let's give it a try. And he's jumping. He is jumping. Praise the Lord. Father who art in heaven, blessed be thy name, thy kingdom come. He is jumping. No longer is Pim trying to descend into the pits, the fiery burning pits of hell. He is jumping through the sky. Wonderful. He clears the pit, he lands, he jumps again, he falls into the pit, but on purpose this time. Everything works. And welcome to programming. Sometimes everything is working perfectly, except you. Or in this case, me. Now, we can try to tune the jump a little bit more if we think that 200 is a little bit too high. You can make it 250, that makes it higher, or you can make it 100 if you want to make it less so. Just remember to keep it at a negative value, because negative means it's going to go upwards. Positive value means it's going to go downwards. Gravity is 400, gravity's pulling him down. Jump speed is negative 200, jump speed is pulling him up. Now, we don't want the debug prints to be visible anymore, so hashtag those out. Because for a lot of reasons. First of all, we might want to have the debug window show us other things, and these are updating on literally every tick. And we don't want that because it's going to be very hard to see what we want to see if we're constantly being bombarded with all these prints. So if you add a hashtag before something, that means you're commenting it out. And if you're looking at my script that I posted in the description below, you're going to see that I've added a lot of little comments in the script to show you what everything does. Probably better than what I'm doing right now, to be honest. Okay. Whew. Okay. Everything is fine. So back in player.gd, we add this line there at the top. At onReady, var underscore sprite colon animated sprite 2D equals $sprite. This is what we think we have. And that's unfortunately our first mistake. Our node is not called sprite. In the scene tree, it's called animated sprite 2D. I screwed up, and it took me quite a while to figure out what the problem was, but Godot just can't find it. Sprite is null because you can't find it, and any attempt to play animation will do exactly nothing because we told Godot to do that. But we don't know this yet when we're coding. We just keep coding confidently because we're also going to add a facing variable. var underscore facing colon int equals 1. So the facing variable is going to be taking the latest input direction, and it's going to turn that into an integer, which is basically just a simple number without decimals, because it doesn't have decimals. It's either 1 or -1. And 1 is for right direction, -1 is for left. So go down to physics process again, our old friend, and we're going to update it. If input direction is bigger than 0.0, so if it's 1, facing is going to be 1. Else if input direction is smaller than 0, facing is going to be -1. There's never going to be any occasion where it's 0.0, but if it is, it's just going to keep facing the direction it was facing. So now we're going to be creating the function update_animation. This function runs continuously and helps keeping our animation behaving correctly. We define the function and have it return void, since it doesn't really return any values, it's just performing an action. Inside the function, the first thing we're going to write is if_sprite is null, then return. And this means that if we don't have a sprite assigned, the function will just exit immediately. It's not going to do anything. And this is just a small safety check to prevent any errors in case we somehow end up without a sprite. Next, we're going to handle flipping the sprite. So when phasing, which we defined earlier, is going to be the same as the direction we're moving in, when that is less than 0, the sprite should be flipping horizontally. So if phasing is less than 0, we set the sprite's horizontal flip to true and it turns to the left. So we're going to try to run the project now. So before we try it, we need to remember to also call this function. And we do that by typing in _update_animation apostrophes next to, or rather below, move and slide. So we're adding this function into the physics function. This ensures that the animation updates every frame of the game loop. So we see here that Pim doesn't flip around. And the reason turns out to be pretty simple. I accidentally used sprite instead of sprite2D up here with a $sign, which means that Godot doesn't know what I'm doing. It doesn't know what sprite is. So we have to change it. So we do this by making sure both references use sprite2D. And once we've done that and we run the game, it actually works. Pim is now turning left and right as we move in those directions. So that confirms that the logic in our update animation is actually correct, and the issue really was how we referenced the sprite node. However, we still don't want Pim to stay as a simple sprite2D, and there is a very good reason for that. A sprite2D can only show a single image. It doesn't support multiple animations. Pim is going to be walking, falling, and jumping, and standing. But because we're using a single sprite, he's not. He's just standing there looking dumb. So we're going to give him a proper animated sprite 2D, and we're going to set up an idle, a walk, and a jump animation. So right now, your player scene should look like this. You've got player, which is a character body 2D. You got a sprite 2D and a collision shape 2D. And sprite 2D, that's Pim, right? That's where we put Pim. It can be flipped, but it can't animate because it's only one single sprite. And we want multiple frames for different states for Pim, so we're going to need an animated sprite 2D instead. So what you're going to do is that you're going to select the player node, right-click and add a child node, an animated sprite 2D, and leave the sprite 2D alone for now. We're going to get rid of it in a bit. This new animated sprite 2D is what is going to handle all of Pim's poses and animations. With animated sprite 2D selected, look in the inspector for the sprite frames property. Click on it and then click new sprite frames, and then click the little sprite frames resource to open the sprite frames editor at the bottom. Sprite frames, sprite frames, sprite frames. So first we have just a default here. So click on it, name it default, and make sure the FPS is something low like 5. Not that it's going to matter for this one because this is just going to be one image. Click the add frames from spritesheet button, the little grid button, and then select spritesheet.png. Change our grabbing to 16 x 16 pixels and just pick the one where Pim is standing still. This is not an animation, it's just one frame, but Godot is still going to treat it as an animation. Next, create another animation. Name it walk, and keep the FPS at 5 for now. We're gonna look into that later in another video, but for now 5 FPS is fine. And we're gonna add some frames from the sprite sheet, and this time I want you to select these 4. So the 2nd, 3rd, 4th, and 5th. Those are going to be the Pim walking frames. So if you now press the play button in the sprite frames editor, you're gonna see him doing his little shuffle. It's a very, very basic, very NES movement pattern, but I think it's got its charm. Now keep in mind what I said way back in the first video. you can technically have way more frames to any movement in an NES game, but since you only have 128 times 128 pixels to work with for all your sprites, try to, rein it in a little bit. Now we're gonna make the final animation. Make a new animation, call it jump. The FPS doesn't matter here, but keep it at 5, and add a single frame where Pim is in a walking pose. We'll call it the walking pose, but it's a jump pose. His legs are slightly apart. He's got a slightly different posture, and 1 frame is enough for this very basic, simple NES style jump. And at this point, we have default, walk, and jump. 3 animations, 2 of which only have 1 frame, and 1 which has 4 frames. And now we're ready to wire this into code. If not is on floor, and if sprite animation is not jump, sprite.play jump. So basically what this does is that if we are not touching the floor, Pim should be jumping. If he's not jumping, he should be jumping. We should be playing the sprite that's jumping, and then return. And if our absolute velocity.x is bigger than 0.1, and if our sprite animation isn't walking, or walk rather, then change it to walk. Else, if the sprite animation isn't default, change it to default. So what all this code does is basically check that if Pim is not touching the ground, he is in the air. So he should be using the jump animation. And if our velocity, if Pim is moving faster than 0.1, which he will always be moving faster than, he should be using the walk animation. And if the walk animation isn't playing, that is to say, if his velocity is less than 0.1, he should be using the default. He should be standing still. And we're gonna hit play again. And now Pim is facing right by default, and when we walk left, he's gonna flip horizontally. When we move, he's gonna play the walk animation, and when we jump, he's gonna jump. When we stand still, he's just gonna stand still. Everything finally works. Now, before we end this video, because we've done so much today, there's something that you might want to fix and tweak. Sometimes there will be a vertical line showing up at the very edge of your sprites. This could be your enemies or your player sprite. And I don't know why that happens, but I think how to get rid of it. So even if you haven't seen those yet, and I haven't seen them in my video, but if they do appear, or rather even if they don't, you can fix this anyway. Go to project setting, go down to rendering, select 2D, and enable snap 2D transforms to pixel. And that forces everything to align to whole pixels and gets rid of those annoying seams. And because we are recreating an NES game where we only had this amount of pixels, this is actually exactly what we want. This might also be a good idea to shrink Pim's collision shape down just a smidge so he can fit under platforms, and we can make sure that his jump speed is high enough that he can get up on the platform that we built. So by the end of all this, Pim should be able to walk, jump, he should be animated when he's moving around, he should be flipping directions, and he should be colliding properly with the world, and of course, he should be falling down pits, if he walks into a pit. We have gone from a static sticker to an actual NES-style character. If you recall, last time Pim was just standing there, now he's actually moving around. So now, finally, we're ready for the next big step. Enemies, damage, and lives in the next episode. So don't worry, we're not tackling that yet. Before we leave, I would like to thank you all so much for all the subscribes and the likes and the comments. It's been kind of overwhelming, to be honest, so I'm very excited to make this. You can probably tell that I put a little bit more effort into this video, and moving forward, I will do my best to keep a higher quality and help guide you along with this. I am by no means an expert in coding, as you could probably tell, So I will sometimes make mistakes, or there will be stuff that I don't know how to fix. But if you notice something that's not covered in the video, just let me know in the comments below and I'll try to reply to it. I'm thrilled to keep doing this, and I'm very excited to see you guys again in a week. Until then, take care. Bye-bye.